Hello everyone, welcome to my video. I am Bhagavati Pradeepa from Computer Science and Engineering Department at Shriram Engineering College. In this video, I am going to explain about dynamic programming, how it is differ from divide and conquer method, properties of dynamic programming, approaches in dynamic programming and its application. Let's move on to the session. Dynamic programming is an algorithmic design technique used to solve complex problems by breaking them into smaller overlapping subproblems, solving each subproblem only once and store their result for future use to improve efficiency in time complexity. From this definition itself, we can say the difference between divide and conquer method and dynamic programming. Divide and conquer method also used for solving the complex problem. It divides the complex problem into subproblems, solve the subproblems first through the subproblems it will solve the complex problem. The main difference is divide and conquer method solve the subproblems again and again for multiple times. It will increases the time complexity. But the dynamic programming stores the intermediate solution for the future use. It is used for solve the optimization problem. So it is simply called as solve once, store the answer and reuse it. There are two important properties: overlapping subproblem, optimal substructure. Overlapping subproblems are the same subproblems present in multiple times. For example, in the Fibonacci recursion tree, fib5, we want to calculate fib5, we should calculate 14 subproblems here. Here fib1, fib2, fib3 are present multiple times. This is called overlapping subproblem. Next, optimal subsolution. Optimal substructures is a final subsolution should be calculated by the optimal solution of subproblems. Here, fib5's optimal solution is calculated by the optimal solutions of fib4, fib3, fib2 and fib1. There are two main approaches in dynamic programming. First one, memoization, and next one is tabulation method. Memoization is a top-down approach. It is used recursion. This method starts from the main problem and goes downwards. This used recursion and store the results of each subproblem. Before calculating a value, we should check whether it is already stored. If it is stored, we should return the value directly. If it is not, we will calculate and store it. So in Fibonacci, we want to calculate the fib3 value, then we should calculate it and store it in the array. Then after that, next time, instead of recalculating, we will simply return the value which is stored in the array. Because of this problem, the time complexity will get reduced from exponential to linear, from big O of 2 power n to big O of n. The next approach is tabulation method. The tabulation method is a bottom-up approach. It starts from the base case and move upwards. It do not use recursion here. In this method, we solve smaller sub-problems first and store all the results in a table and build the final solution. Final solution step by step using iteration. In this example, Fibonacci, we store fib0 and fib1 first, then using looping iteration, we will calculate fib2, fib3 up to fibn. This method also gives time complexity of big O of n, but it is avoid recursion stack overhead. Applications of dynamic programming: knapsack problem, longest common subsequence, matrix chain multiplication, coin changing problem, subset sum problem. Advantage of dynamic programming, as we discuss in this video: reduce time complexity, avoid repeated computation, provide optimal solutions, efficient for large and complex problem, improve overall performance. Thank you.